This drawing isn't flat. At least, your brain doesn't think so. It looks like it has depth and texture, but it's really just layers of microscopic particles stuck on paper. Today, I want to show you the science that makes colored pencil art look real, the optics of pigments, and the neuroscience of how we see color. Each colored pencil stroke deposits pigment particles about 0.1 to 10 micrometers in size. These particles have a specific refractive index, meaning light bends when it enters them, and that bending determines how much light they absorb or reflect. James Clerk Maxwell showed that all visible colors come from mixtures of different wavelengths. Pigments behave the same way. Their molecular structure absorbs some wavelengths and reflects or scatters the rest. A pigment appears blue because its molecular structure absorbs longer wavelengths and scatters shorter ones back towards your eye. This scattering is called diffuse reflection, and it is central to how drawings create realistic color. Light pencil layers scatter light through air gaps, so color looks pale and grainy. Adding layers compresses pigment, smooths reflection, and makes color look richer. Depth isn't real, it's a light illusion. Dark areas absorb light, light areas reflect it, and your brain reads those differences as 3D form on flat paper. Your brain invents color. Inside your retina are 3 cone types. Cones are light-sensitive cells crucial for color vision, and they each peak at different wavelengths that correspond with a different range of colors. The cones in your eyes send electrical signals to your brain, which blends the signals to create color. But cones don't work alone. These signals are combined into opponent process channels, which are neural pathways that compare 2 color values. We have 3 main channels: red versus green, blue versus yellow, and light versus dark. These channels work like seesaws. When one side goes up in activity, the other side is suppressed in perception. If brightness increases, perceived darkness decreases. Opponent processing compares visual signals to better notice differences in light. This makes edges stand out more clearly, helping us easily see shapes, depth, and changes in lighting. That's why even subtle shading, one extra layer of pencil, can suddenly feel like real depth. These 2 gray dots are physically identical, same pigment, same brightness, but your brain refuses to see them as the same. This is because of color constancy. Opponent color channels work like seesaws. Emphasizing one color suppresses its opposite. An orange background biases perception toward yellow, making gray look bluish. A blue background biases blue, making the same gray look yellowish. The shift comes from perception, not the pigment. That's why purple shadows and green skin appear real. Realistic art isn't about copying reality, it's about understanding how we see it. Colored pencils are simple tools, but the science behind them is extraordinary.